Now let's start our discussion on our GABA A receptor modulator with benzodiazepines. So these are the common generic names or available products under benzodiazepines in the market. Chlordiazepoxide, diazepam, prazepam, halazepam, flurazepam, quazepam, clorazepate, oxazepam, lorazepam, and temazepam. Consequently, these drugs are dependent, their duration of action is dependent mainly on the rate of their metabolism and their active metabolites. So the most active among them is our oxazepam. The first position for modification of our pharmacophore is adding a small alkyl group, for example, methyl. This is present in our nitrogen and it is both available for our drug diazepam and temazepam. So that methyl group is very useful or is required for optimal activity for CNS depression. The next one is benzodiazepine like oxazepam, lorazepam, and nitrazepam simply have hydrogen at first position. So all of these drugs have hydrogen at our first position instead of methyl group. So remember, hydrogen and small alkyl is advantageous for CNS depressant activity. The next position would be in our number 2 position. Carbonyl group at second position is essential for activity. Chlordiazepoxide, this is the first benzodiazepine that was developed and it doesn't have keto group at second position. So it needs to be metabolized following oxidative deamination. So there it will be removal of your amine and forming a carbonyl in our second position, which is desirable for CNS depressant activity as mentioned in the first statement. So there is now carbonyl in our position 2 for demoxipam drug. The third position is needs polar functional group. This polar functional group will allow increased availability of the drug for excretion. If there is faster excretion, there will be decreased duration of action in the body. So it helps our drug excretable and safe for use. So example of drugs which has hydroxyls in our third position is the lorazepam, temazepam, and oxazepam. Oxazepam and lorazepam are highly polar and can be excreted directly without phase 1 metabolism. So it can undergo phase 2 directly due to the presence of hydroxyl in our position 3. Temazepam also share a little phase 1 reaction. It undergoes demethylation and converted into oxazepam and then excreted. But there is a little phase 1 due to the presence of our hydroxyl. It's easier to metabolize it and excrete it in the body. The fourth position in all benzodiazepines, we can observe an unsaturation at fourth and fifth position. This is essential and required for activity, and saturation of this double bond may decrease the activity. So it has to remain single bond to promote CNS depressant activity. In our fifth position, a simple aromatic ring like phenyl group is optimal for activity. Again, all benzodiazepines, including fused benzodiazepine ring systems, have a phenyl group at fifth position. For example, drugs like diazepam, nitrazepam, oxazepam, temazepam, and chlordiazepoxide, they all have a phenyl group at fifth position. Another example is flurazepam. It has fluoro group and clonazepam has chlorine group. So in our fifth position, which has a ring attachment, the ring attachment there, in if substituted in ortho position, there will be increased or enhanced CNS depressant activity. The seventh position is very important also because it determines potency of benzodiazepine. So election withdrawing groups like halogens or nitrogen group increases the activity. So this is the entire picture of the general structure or the SAR of our benzodiazepine. Aromatic or heteroaromatic ring is required for the activity that may participate in stacking with aromatic amino acid residues of the receptor. So an electronegative substituent at position 7, which is represented there by letter X, is required for activity, and it needs a more electronegative element that can promote or can increase higher CNS depressant function. Again, substitution at position 1 or 3 may increase lipophilicity, such as in our diazepam and lorazepam. And I emphasize now that in position 6 and position 8 and 9, that positions should not be substituted because it will diminish the property. Now, the phenyl ring, the ring C, at position 5, as presented earlier, is useful for a CNS depressant property. So substitutions on ring C are only allowed again in ortho position or in 1-2 position. And addition or the substituents that can be added are those electron withdrawing atoms such as our chlorine and fluorine for lorazepam, midazolam, and clonazepam. Okay, removal of that ring C results in loss of agonist activity. So although there is high affinity binding to your benzodiazepine site on the GABA A receptor, but it is still produces significant decrease if you remove your phenyl ring. If this phenyl group also in ortho position or diortho, which is 2,6 position, is substituted, it can produce a pronounced CNS depressant property. While if you have a substitution on para, which is 1,4 position, that will decrease activity. Okay, in ring B, which is called as diazepine ring, okay, saturation again in our 4 and 5 or double bond or a shift of our 3 to 4 position on the saturation will decrease activity. So alkyl substitution at the 3 position also decreases activity, and substitution with the 3-hydroxyl will not decrease activity. The presence or absence of the hydroxyl, the 3-hydroxyl group, is important pharmacokinetically. So that compound there will determine our metabolism and excretion, as mentioned a while ago. The 2-carbonyl functional group is very important for activity, as well as the nitrogen atom in position 1. So we try to look at the structure, and that is the basic or the foundation of our different benzodiazepine and the reason for their duration of action and their properties following pharmacokinetic aspect. The next group that is related to our benzodiazepine, which also acts in the benzodiazepine receptor or called as benzodiazepine receptor agonist, is called the triazolobenzodiazepines. So we have here triazolam, alprazolam, and midazolam. So I did not include here the structure. So for your activity on this section, I want you to look for the structure of our 3 drugs and encircle the pharmacophore from the word itself, triazolobenzodiazepine. So these compounds are short-acting because they are metabolized rapidly by hydroxylation of the methyl substituent. So include in your activity, identify where is the methyl substituent that is responsible for easy hydroxylation and excretion of our triazolobenzodiazepine. So the next one, we have the non-benzodiazepine drugs, the zolpidem, which has the pharmacophore imidazopyridine, ezopiclone, which has the pharmacophore cyclopyrrolone, and zaleplon, which has the pharmacophore pyrazolopyrimidine. So for another activity on this part, you look for the structure of these Z drugs and identify the mentioned pharmacophore. So that will be all for our benzodiazepine discussion. I'll see you next time on the next CNS depressant, which is our barbiturates. Thank you for listening.